In this video, we will be discussing functions in R. A function is a set of instructions or statements that complete a specific task. Typically, a function has some input in the form of arguments, a body of statements that actually does the work of the task, and often an output or return value, which is the result of the function. Additionally, functions are objects in R. And in addition to statements that make up the actual function, function objects include an environment, which captures any symbols present when the function itself is created. And we'll talk more about what that environment is later in this video. To write a function in R, we'll use the function keyword, followed by an argument list in parentheses, and then finally the body of the function, which is a statement or a compound statement. As an example, let's write a function that computes the mean of the values in a vector and then returns that mean upon completion. So as we said, we start with the function keyword, followed by an argument list in parentheses. So let's call our input vector x. And for the body, we're going to start a compound statement and then use the sum and length functions to actually compute the sample mean and assign it to the variable m. So this line now computes the sample mean and then stores that result in m, as we said. But in order for the result to be used outside the function, or maybe another way to say this is, for the caller of the function to know what the computed mean is, the function must output or return the computed value back to the caller. So to do this, we will explicitly use the return keyword to show that we are returning the value m from our function. So I type return, and in parentheses, we put our variable m. Now we have written a function that computes the mean, but how do we use it? Well, first, we need to give it a name so that we can actually call it. And we do that by assigning the function itself to a variable, just like we would in any other expression. So I'm going to go back to the beginning and write my.mean, and then use the left arrow to assign the function to the variable my.mean. And now that we've assigned it a name, we can actually call our function and pass it some input data. So using this name, my.mean, followed by parentheses, I'm going to pass a sequence 1:4, and then run the code block. And we see in the output, we get the mean of the values 1 through 4, 2.5. Now, there's a lot going on here, but we're going to take this slow and we're going to look at it one piece at a time. So let's start with arguments, or the inputs to our functions. In R, arguments are passed by value, meaning that if we modify the value of an argument which is passed to a function from within that function, the modification is only visible within the function itself. So to help us understand this, let's write a function that attempts to modify one of its arguments. In this case, we're going to modify a vector, and then we're simply going to print that modified vector. So we're going to call this function replace.print, and just like in the previous example, we write function followed by an argument list. So in this case, it's going to take a single argument. We're going to call it x. And to modify this input vector, and for this, we are simply assuming that x is a vector, but to modify it, we're going to index the first element and then assign to it the value 42. And after this, we're simply going to print that vector x, and that will complete our function. Now, to test this, we need a vector, right? So let's call the vector v and give it the values 1, 2, and 3. And now we're going to call replace.print and pass it v. And then finally, we're going to print out v again. Before we run this, let's take a moment to review what's actually happening here. We start with a vector v containing the values 1, 2, and 3. We then pass this vector to our function replace.print, and this function assigns the first element in the vector a new value, 42, and then it prints that modified vector. The question now is, after the call to replace.print, will the vector v, which is declared outside of the function and passed to it as an argument, have the values 1, 2, and 3, or will it have the values 42, 2, and 3? And the answer is, if r was passed by reference, which it's not, then v would have the values 42, 2, and 3. But because r uses pass by value, which effectively means the function is getting a local copy of the arguments, this vector v will remain unchanged. And when we run the code block, we see that in the first line, which comes from the print inside the function body, shows our modification. And the second line, which contains the output from the line print v, shows that the vector v remains unchanged outside of our function, right? It still has the values 1, 2, and 3. Now, in addition to being passed by value, R also uses something called lazy evaluation. This means that a passed argument is not evaluated until it's actually used. So if you were to write in some expression in the argument list of a function, the expression itself may not be evaluated if the function does not use that argument. So to see this, we're going to create a pair of functions. The first is going to be my.print, and it's simply going to output the value passed to it and then return that same value. Now, the second function is going to be called lazy. And this is going to take 3 arguments, but it's only going to use 2 of them. So the function takes x, y, and z, and then outputs x and z while completely ignoring y. When we call these functions, I'm going to call the lazy function, and for each of its 3 arguments, I'm going to pass the output of the my.print function. So I'm going to write lazy, and then for the 3 arguments, I'm going to call the myprint function, passing it different values. So myprint 1, myprint with 2, and then myprint with 3. And when I run this, we see that myprint 1 and myprint 3 were actually output, followed by lazy with values 1 and 3. The last line should be clear, right? Since the function lazy outputs the first and last arguments and ignores the second. But you see that myprint with the value 2 did not execute, and this is due to the lazy evaluation in R. The argument y was never used in the lazy function, so the interpreter did not bother to call the myprint function that was in the argument list. And this is definitely something to be aware of. We've already seen this with the switch function, which actually depends on this feature. But if you really need each instance of my.print to be evaluated here, then you should call them outside of an argument list and then assign their outputs to variables, which can then be safely passed as arguments to a function. Typically, function arguments should be given in the order prescribed in the function declaration. So I'm going to paste a function here, f, and the function f is going to take 3 parameters, a, b, and c, and then simply print them out, each one on a different line. So if I now call f with the arguments 2, 1, and 3, and run the code block, we see that we have a equals 2, b equals 1, and c equals 3. And this shows us that the arguments 2, 1, and 3 were in fact assigned to a, b, and c in the order prescribed in our function declaration. R does allow us to specify the argument names when calling a function. And because of this, we can modify the order however we see fit. So if I call the function again, and this time I say c equals 3, a equals 2, and b equals 1, and I run the code block, we'll see that we get the same output as the previous example, even though I've given the values in a different order. The difference is the argument names were specified in this example, and so R still knows how the values are to be assigned, even though they were given out of order. While we can specify argument names, we're actually not required to specify all of them when calling a function. If we only include a subset of the names, then the named arguments will be applied first, and any unnamed arguments that we pass will be applied to the remaining function arguments in order. For example, if we call f again, we pass the value 1 without an argument name, followed by the values for a and c, where we specify a equals 2 and c equals 3, and then we run this code block. Notice that in the output, b received the value 1, even though it was not first in the argument list specified in our function declaration. This is because the named arguments, which included a and c, were applied first, and then the only remaining argument, b, was assigned the unnamed value 1 from our actual function call. In fact, if I were to change the order of the arguments altogether, you'd see that we get the same result. When we define a function, we can specify that some or all of the arguments have default values. A default value for a function argument is the value that that argument will receive if the user that calls the function does not specify another value. So to set a default value for an argument, we use the equals operator followed by the value that we want. For instance, I can write a function, myApply, that takes 4 arguments, where the 4th argument is expected to be a function, and myApply simply calls that function and passes the first 3 arguments here as parameters to that function. So to do that, I simply call fn, and then in parentheses, I pass the arguments a, num, and string. And now, let's say I wanted some of the arguments to my function myApply to have default value. To do so, I'm going to add an equal sign following the argument. For instance, num equals 42. And maybe str equals default string. And maybe I want the default function to be the cat function. And now, with these default values in place, I don't actually have to specify all the arguments that this function requires when I call this function. Any missing arguments will use the defaults that are given here. So if I call my.apply and I pass it a single argument like the string a, then we see the output here is the string a followed by the number 42, which was the default value for num, followed by the string default string, which was the default value for argument str. And myApply used the cat function to output all these values for us, even though we did not specify this in this particular call to my.apply. I can, of course, replace any of the default values by providing additional arguments to the function. For instance, if I wanted to replace the string argument, I could say string equals b. And now we see the output here displays our string b as opposed to the default value. And of course, this works with any of the other arguments as well. In fact, the only argument that we need to pass is a, since it's the only one who does not have a default value. And then for one last example, we'll pass 88 for the argument a, and then we'll change the function from cat to paste. We'll actually paste all of these arguments into a single string and return that string. In the previous function examples, we've seen the use of the return keyword to explicitly return values from the function. So like in this example here, this function square will take the value x and then return that value squared. So if we call it with the value 10, we'll see that it outputs 100. If you recall from our description of compound statements, a compound statement will take the value of the last statement evaluated within it. The body of a function is a statement or a compound statement, so the function will return the value of the last statement or the value of the compound statement even without an explicit return. So if I repeat the square function, but this time I omit the return keyword, we're still able to call it with the value 10 and get the value 100 as output. So for simple functions, you may wish to use this, but if your function is more complex, and especially if it has multiple possible return points, then it's better to explicitly use the return statement.